This session, I will start this by discussing the exercises related with calculating variance and standard deviation. In the previous session, we have discussed about the formulas which we can use to calculate the population variance, population standard deviation, then sample variance and sample standard deviation. And as the last part of the previous session, we have discussed about the pros and cons of the variance and the standard deviations. And here I will take the first example exercise. The table given below contains the marks obtained by 10 students for GRE examinations, and here you are asked to calculate the standard deviation for these marks. Here you can see that it is not given as a group distribution. Here we can see that the individual values for these students have given for us, and now we can find out um, the standard deviation. Then here we are taking the sample standard deviations only. We are not going to discuss any population parameters in this session. Then to find out the sample standard deviation, we can simply obtain the sample variance, and thereafter we can obtain the its square root to get the sample standard deviation. Since we do not have any group frequency data, we can use these two equations to obtain variance and the standard deviation. Now we will see the equation we are having. We can get the variance. For the variance, we can use the equation to get the variance. S squared is obtained as summation of x minus x bar divided over n minus 1, and standard deviation was obtained as the summation of x minus x bar divided by n minus 1, and the square root is considered. Now if you noted down the values that we can take for x, first I am writing down the values of x. Values of x were given as for the first student it is 43, then 48, 65, 57, 31, 60, 37, 48, 78, and 59. These are the values that we can observe as the marks, and accordingly, according to this equation, what we need to do is first we need to have the summation. Here it should be x minus x bar squared. These values has to be obtained. Now we know the values of x, and we can find out the value of n. Here it according to the provided example, it has given for 10 student marks of the 10 students. Then the data we are having is value for n is equal to 10, and now we need to take the values of x bar, as x bar is needed to calculate. It can be taken as summation of x divided by n. Therefore, as the first thing, what we can do is we can obtain a value for x bar. X bar can be obtained as summation of x divided by n, which equals to sum of x. It is 43 plus 48 plus 65 plus all these values. The last few values I am taking 78 plus 59. Then divide all these by all together. There should be 10. It is because 10 observations are there. Then divide by 10 gives the value for x bar. And we can see that this calculation leads to the value, the summation, it is 526 divided by 10 leads to the value as 52.6. Now what we need to do is we need to find out the value of summation of x minus x bar squared. Then if you need, you can obtain the column as x minus x bar, and then we can obtain the next set of values. It is the square term of the values that we have obtained here. Then what we can do is we can take 43 minus 52.6 then we can get it as minus 9.6. Then the square term of this would be equal to 92.16. Similar manner, if you are taking the next value, it is 48 minus 52.6. It is just 48 is the value here, and 52.6 is the value which can use here. Then it leads to the value as minus 4.6. And if you take its square term, then we'll get it as 21.16. Similar manner, we have to obtain the values for others as well, and we can see that the set of values which we can obtain for these two columns as. Now we can see that these are the values that we can obtain for x minus x bar and x minus x bar squared. Now what we need to do is we need to take the summation of x minus x bar squared. It means that we need to take the summation of this column. We need to take the summation. If you are taking summation, then we will get it as summation of x minus x bar. Here we had the square terms and summation is obtained, and it will be equal to 758.40. It is the summation that we are getting. Now we can apply the equation. Here, first we'll take the value for s squared. S squared can be obtained as the summation of x minus x bar squared divided by n minus 1. Then this leads to 1758.40 divided by 10 minus 1, and accurate to two decimal places, we are getting this answer as 195.3. Therefore, this would be the variance for the data set, and here we are asked to calculate the value for the standard deviation. Then we need to get the value for s. Then we have to take the square root of this 195.38. Then we can get the square root as accurate to two decimal places, it is 13.98. Therefore, this is how we are applying the equation to find out the variance and the standard deviation if we are having this individual data set like this. It is the first exercise we are asked to do, and for the second exercise, it is given as using the classes. It is quite as the group frequency distribution. First, they are having the classes, and for each class, they are having the frequency. It is the first class is 0 to 9. Then the classes are here. It's 10 to 19. Classes are given in this way, and the frequencies are given as 8, 12, 17. 14, 9, 7, and 4. Here it is the classes are just we can say it as the variable x, and the frequency we can say it is the value for f, but since it is a class, then we have to find out the generalized value for this. Then first, as the first thing what we need to do is we need to calculate a class midpoint. Class midpoint is considered as the generalized value for the class. Then as the first thing we need to calculate the class midpoint. Therefore, apart from taking this as x, then hereafter we will consider class midpoint as the value of x. It is because a class represent a value range, but here we can see that midpoint is just a single value which can be considered to represent the entire class. Then using the appropriate calculation, we will get the class midpoints in the following way. This is 4.5. Next value would be 14.5 and 24.5, 64.5. Then, according to the equation we are having for variance, variance is given for group data. Then it is summation of f times x minus x bar squared divided by n minus 1. And here we can consider n is equal to summation of f. Then we need to find the value here. The summation can be obtained as summation of f. Then summation of f can be obtained as the summation of the frequency values. It is 8 plus 12 plus 17 plus 14 plus 9 plus 7 plus 4 leads to the value as 71. Now, what we need to do is we need to find out the values of f, x, and x bar accordingly. As the first thing, what we know is we know the value of f, we know the values of x, and now we know the value of n, which is equal to 71. Then we need to find out the values of x bar. X bar can be obtained as summation of fx over summation of f. Summation of fx, we need to find out the column including the summations. It is fx is now need to be find out fx in the sense multiplication of x with f. Then for the first row we'll get the value as 36, 8 into 4.5, then 12 into 14.5, 174. And the next value would be 17 into 24.5, 416.5. Then 14 into 34.5, 483. Then 9 into 44.5, 400.5. Then 7 into 54.5, 381.5. Then 4 into 64.5, 258. Now we need to take their summation. It is because here we got summation of f. Now we need to get the summation of fx. Summation of fx is need to calculate. Then we'll get it as get the summation as 2149.5, and we can apply or substitute it in the equation. Then we'll get it as 2149.5 divided by summation of f, it is 71. Then we'll get this accurate to two decimal places. It is 30.27. 30.27. Now we need to calculate the next column. The next column, if you need, you can calculate it as x minus x bar. But apart from making this as somewhat a big calculation, I will directly calculate x minus x bar squared values directly. Then it will be easy for us for this calculation. Then here we can see the values of x. Then we know the value of x bar is 30.27. Then I will directly calculate the values for x minus the mean value. It is 30.27 squared terms. Then for the first one, we'll get it as 664.09. Then 248.69. Next value is 33.29. 17.89. 202.49. 1171.69. Now we need to take the next column as f times x minus x bar squared. Then we need to get the multiplication of x minus x bar squared column with the value of the frequencies we are having. Then the first value can be obtained as 8 times 664.09, which is equal to 5312.72. Then 12 multiplied with 248.69, it is 2984.28. Then 17 multiplied with 33.29, 565.93. Then we are getting 14 multiplied with 17.89. It is 250.46. Then 9 multiplied with 202.49, 1822.41. Then 7 multiplied with 587.09, 4109.63. 4 multiplied with 1171.69 is 4686.7. Then we need to get their summations. It is because we need to get the value for summation of f times x minus x bar squared. Here we are having the values for f times x minus x bar squared. Then we need to get their summations there. So we can get summation as 19,732.19. Now we can apply or substitute it in the equation. Where s squared is given as summation of f times x minus x bar squared divided by n minus 1, which gets the value as 19,732.19 divided by 71 minus 1. We'll get it as we'll get the value accurate to two decimal places as 281.89. Therefore, taking the square root of the this answer, we can take the standard deviation. Then the standard deviation gets the value as 16.79 accurate to two decimal places. Therefore, this is how we are applying the equation, which is for the uh, group frequency distribution to finding out the standard deviations. And now we will move for the discussion for the next measure that we can use to measure the dispersion. Here we will consider the coefficient of variation, which is a combination of the standard deviation and the mean. Then we can define the coefficient of variation as the standard deviation over mean into 100%. Therefore, generally the coefficient of variation is presented as a percentage value. Then we can take the coefficient of variation, which equals to the standard deviation over the mean value. Then we can define it for the population parameters as using the sample statistics. Then we can have this coefficient of variation as sigma over mu. It is the sample standard deviation over sample mean into 100%. Then for this using the sample data, we can take it as coefficient of variation equals to sample standard deviation over sample mean into 100%. Using the coefficient of variation, we can identify whether the data are stacked or whether it has a higher variability. Therefore, to check for the variability, standard deviation is for a single set of data. But if you need to compare two sets or more than two sets of data, then standard deviation would not be be a much appropriate method to test the variability or comparing variability of several data sets. In such situations, we can use the coefficient, the technique of coefficient of variation to check the variability of two given what we are saying as two given data sets. Here we can see that in the there are two factories engaged in the same industrial area, and their weekly average wages in rupees are given below. For the standard deviation is given in follow. Which factory pays out a larger amount as weekly wages? The first part is asking about which factory, A or B, pays a large amount as the weekly wages. Here they are asking which factory pays more. To check whether which factory pays more, what we need to take is we need to check for the total that they are paying. Therefore, we can have the calculation in this way. According to the given information, we are having the average values, we are having the sample standard deviation values, and we are having the number of workers, or the count we can say. The averages are given as 34.5 and 28.5. 34.5 and 28.5 for the factory A and factory B. Standard deviations are given as 5 and 4.5. 5 and 4.5. And the number of workers in each factory is given as 476 and 524. 476 and 524. In the first part, it is asking which factory pays more for the as the wages. Therefore, first we need to compare the totals, then total for factory A. It is because they are asking which company pays more. Then total for factory A, we can get it by multiplying the average with the total count that they are having. It is 34.5 multiplied with 476. Then we can see the amount is 16,422, and we can check for the total for the factory B. It is 28.5 multiplied with 524. Then we can see it is 14,934. Therefore, we can conclude that the factory A pays more as weekly wages. It's because this is the total that the factory pays, and 14,934 is the amount that the factory B pays. But actually, in this example, we need to go through this second part, which factory A or B has the higher variability. When we are discussing about the variability for a particular data set, then we can simply use the standard deviation. But here we can see that there are different averages and different counts have used. Therefore, it is better to take the coefficient of variation. Therefore, we'll calculate the coefficient of variation for factory A. It can be written as coefficient of variation can be obtained as S over X bar, where the sample standard deviation over mean multiplied with 100%. Then S is given as the sample standard deviation, it is 4. Then mean value is 34.5 multiplied with 100. We can get the value as then we'll get the coefficient of variation as 11.59, and we can take it as a percentage. Then coefficient of variation for the factory B, we can take the values, it is 4.5. 4.5 is the value they have given for standard deviation. Then the average goes 28.5 and multiplied with 100. You can see that the variability is 15.79. Therefore, we can see that factory B has the higher variability. Therefore, to compare two separate data sets, we can use the have the comparison for the factory A and factory B. We can use the coefficient of variation on that matter. It is because sometimes some may be argue that why we cannot use the standard deviation. It is because if we are using a particular data set, we can use the standard deviation or the variance to measure the variability of a particular data set. But if it is needed to compare or have the comparisons for set of data sets, then we cannot use the standard deviation alone. In that situation, what we can do is we can have the measure as the coefficient of variation. Since it is given as a percentage value, we can measure. If the coefficient of variation has a higher value, then we can say that it has a higher variability. If the coefficient of variation is just a lower value, then we can say that it is a lower variability. And here we can see that it is another example is given exercise which you can try. The index numbers of price for cotton and coal shares in 2013 has given. Then you are asked to find out which share index has the higher variation. Since these are two different value set of data we can get for cotton shares and coal shares, it is because their values will be comparatively different. Then for a particular year they have provided the values. Then here also we can have the coefficient of variation measure as to compare these two variables. Then what we can do is for the cotton shares we have to find the mean value and the sample standard deviation. For the Kolshas also we have to find the mean value and the sample standard deviation, for sample standard deviation separately, and accordingly we have to obtain coefficient of variation for Cortices, as well as we need to obtain coefficient of variation for Kolshas as well. Therefore, you can try for this exercise by yourselves. Since the data is provided, you can use the method which I have explained previously. Now we will move for the skewness. This is another measure that we are discussing for a distribution. First, we have discussed the measures of central tendency, and then we have discussed the measures of variation. Now we will discuss about the measures of skewness. First, we will have a look what is actually meant by the this measure of skewness. The skewness is a measure of the asymmetry of the probability distribution of real valued random variable about its mean. Here, using the skewness, what we are measuring is we are checking whether the distribution is symmetric or not. The simple idea in this skewness is we are checking whether the distribution is symmetric or not. Symmetric in the sense, if you are consider the mean value, the left side of the distribution and the right side of the distribution from the mean value would have the same area, or it should have the same distribution. But if we can see a majority of data has just given in one of the ends, whether it is in the positive end or the negative end, then we can say that these distributions are skewed distribution. Here we can say that for the skewness of distribution, it can be positive, negative, or zero, or sometimes we are saying it as undefined. For some probable distributions, it is really hard to find out the skewness based on the graphical parameters we are using. And here we will find out the graphical presentation for the skewed distributions and the symmetric, or this there is a distribution which is having no skewness. If it is a negatively skewed, here we can see that a tail is moving for the negative direction of the distribution. Therefore, if it is a negatively skewed distribution, then we can see that the majority of data in the positive side of the distribution, that is and we can see there is a it is just like a decaying tail, then decaying in the distribution for the negative side, or tail is in the negative side, then we can say such distribution as the negatively skewed distribution. And if there is no any tail for a particular side for the both ends, if you can see somewhat a symmetric figures in the left end as well as in the right end, then we are saying such distributions having no skewness, and those distributions are said to be symmetric distribution. If it is a symmetric distribution, generally we are having mean, median, and mode. We'll get all three measures as a same value. Then we are saying an example for this no skewed distribution as the normal distribution, and such distributions are supposed to be the symmetric distributions as well. And the next term is the positively skewed distribution. Positively skewed in the sense we can see a tail in the most right hand side of the distribution. Therefore, the majority of data is on the in the left hand side of the distribution, and we can see that there is somewhat a decaying pattern for the right hand side in the positively skewed distribution. Therefore, here this is the graphical presentation. Using the graphical presentation of the distribution, we can simply identify whether it is negatively or positively, or else there is no skewness. Here, then if a distribution is supposed to be normal, there is no skewness in the sense that the value for skewness would be equal to 0. And here also we can see positive is skewed, there is a tail in positive side, negatively skewed, tail in the negative side, and normal curve in the sense there is no any specific tail for left side or the right side. And we can have this again the graphical presentation using the box plot. Using the box plots also we can find out the skewness of the distribution using if it is a normal distribution, if there is no any particular tail for left side or right tail, you can see that normal distribution having if you are drawing a box plot for the normal distribution, you may get similar areas for these two boxes. Here we are measuring, we are having q1, q2 and q3, first, second and third quartiles in the box plot. Then we can see that the area in the this area for part A would be equal to area for part B. Then such distribution is a normal distribution. Then for a normal distribution, we can see that the length between here I will take quartile 2 and quartile 1. If you take the distance between quartile 2 and quartile 1, it would be similar as the distance between quartile 3 and quartile 2. Therefore, you can see that equal distances in the in these two values q1 and q2 as well as q2 and q3 if it is a normally distributed. If it is positively skewed, then this part would be much more larger than comparatively the B is larger than A, then it means that the most right hand side has a larger value. Therefore, we can say that the majority of data falls into the left side, and we can see that minority in the right side. Therefore, this q1, q2 and q3, if this q3 minus q2 is greater than q2 minus q1, then we can say it is a positively skewed distribution. Therefore, just by seeing the box plot also we can comment on the skewness of the distribution. Here, if we are having two equal parts, it is normally distributed. If the right side box is is somewhat larger than the left side box, then it is a positively skewed distribution. And for the if we can see for if the for the box plot having area or the distance between q1 and q2, which is somewhat larger from the distance between q2 and q3, then if this distance A is quite larger than distance B, then we can say that it is a negatively skewed distribution. Therefore, you can see there is somewhat a larger part in the left side. It would be quite given as a tail. Therefore, if you draw this, then you will get the distribution in this way. If it is a positively skewed, then you will get the distribution in this way. But if it is a negatively skewed distribution, you will have a tail for left side and somewhat less part for right side. Therefore, this is how we are identifying the skewness of the distribution just by seeing the box plot. And as a measure for calculation of the skewness, we can have the Pearson's coefficient for skewness. Here we have defined they have defined two measurements for skewness, which is given as Pearson's first coefficient of skewness and the Pearson's second coefficient of skewness. For the as the first coefficient of skewness, it is calculated using the mean, mode and standard deviation. If you have the values for mean and mode, then mean minus mode over standard deviation gives the Pearson's first coefficient of skewness. Therefore, here we can see that if we are getting a positive value, then we can say it is positively skewed. If this gets a negative value, then we can say that it is a negatively skewed. And if we get the value as 0, then we can say that there is no skewness, or we can say it as symmetrically distributed. Now you can see that if we can get 0 if and only if we are having the mean and mode having the same value. Therefore, in the previous chart also you can see that if there is no any skewness, mean, median and mode will have the same values. Therefore, we can see that for the first coefficient of skewness, mean minus mode over standard deviation gives it, and for this as the second coefficient, we can get it as 3 times mean minus median over standard deviation. You can try for an example which we have used previously. By substituting the mean, mode, and standard deviation, you can compute the first coefficient of skewness, and to get the second coefficient of skewness, again we will get it as 3 times mean minus median over standard deviation. But even though you are using first or the second coefficient, you should not get contradictory results. It is because even though you are using first or second, you must get the similar result. The only difference of these two is here we are using mean, mode, and standard deviation to calculate the first coefficient for skewness, and mean, median. Once you have the values for mean, median, and standard deviation, we can use the them to calculate the Pearson's second coefficient of skewness. And these are the things which I need to discuss related to the skewness of a distribution. And apart from that, uh, the next measure that we can have for any given distribution is the cortices. Cortices is considered as the sharpness of the peak of a particular distribution. Therefore, generally we can see that there are some distributions having a very sharp peak, and just having a normal peak, and sometimes the peak is quite as a flat one. Therefore, if you are having if you take a normal distribution by referencing normal distribution as having the cortices as 0, then it is said to be a mesocortic distribution. And if it is having a very sharp edge, then we are saying such distributions as the leptokurtic distribution. And if you can see that somewhat a flat surface as the peak of a distribution, then such distributions are said to be the platykurtic distributions. Therefore, just by seeing the shape of the distribution, we can identify whether it is leptokurtic, mesokurtic, or the platykurtic. And the next thing we have to do is here we are taking the reference as the normal distribution. And for the normal distribution, we are setting the value of cortices as 0, and we are naming such distribution as a mesokurtic distribution. And this is all what I need to discuss for this session, and thank you all for your participation.